Hi guys, I'm Abubakar Hamisu, and I'm here to clarify the doubt that I've been receiving complaint about the issue of electronic configuration. First, when approaching any problem with regard to electronic configuration, first we have to know the number of subshells or orbitals that we have to use to analyze or identify the electronic configuration of a particular element. Now, the basic orbitals we have are the s, p, d, and f orbitals. My fellow viewers, note that each and every particular orbital has a maximum number of electrons it can occupy. For the s orbital, it has maximum of only 2 electrons. Anything 3, 4, 5 is not a territory of the s orbital. Likewise, p orbitals, it has 6 maximum number of electrons. D orbitals has 10, while F orbitals have 14 numbers of electrons that it can occupy. Now, how can we analyze the electronic configuration of an element? For that, let's select some basic elements like 5 and then give out the electronic configuration. Let's say calcium, let's say chlorine, let's say sodium, let's say potassium, let's say 5 argon. And those, let's analyze the electronic configuration of these 5 basic elements that we have. For that, let's take up the calcium, is the number 20th element in the periodic table. And mind you, using this electronic configuration, we'll be able to analyze and identify a particular element to which group or period and to which block of the periodic table it belongs to. For now, let's analyze this of calcium and the other elements that we have just let example by. Now we have 1s2, 2s2, 2p6, 2p6, we have 3s2, we have 3p6, and we have 4s2. There is case to be noted in this juncture. Why should we write 4s instead of 3d? We are following this in alphabetical order. Alphabetical order. Sorry, not alphabetical order. We are following them according to the numbers of sub-energy levels they contain. But look, here we have 3p instead of 3d, then we will now put 4s. Why? The reason is that 3d has a high number of energy than 4s. Therefore, 4s have to come first before 3d. In any of the example you are going through, make sure 4s is accompanied first before the 3d comes. We'll see that case in the later examples. Therefore, now let's calculate the number of electrons present in this particular element. Here we have 2, 2, 4, 6, 10, 12, 18, 20. Therefore, calcium has a number of 20 electrons. And now to analyze the particular group to which calcium belongs to, we now said it belongs to group 2. This is group 2. Calcium belongs to group 2 of the periodic table. Group 2. This is not clear at all. It's giving me fundamental errors. And it belongs to period 4 of the periodic table. And nevertheless, it is what? It's one of the S block element. One of the X block element in the periodic table. And so applicable to, let's say, chlorine. Chlorine has a number of 17. Chlorine 17 as the atomic number. By calculating its electronic configuration or presenting, we now say 1s2, 2s2, 2p6, 3s2, 3p6. This is how many? This is 4, this is 10, this is 16, this is 16, this is 18. We have exceed. Therefore, we have to adjust. We are to adjust the numbers of the p orbital. Therefore, it becomes 5 instead of 6 now. It became 5. Therefore, now in this case also, to know to which group chlorine belongs to, we are to add the numbers in s orbital and the number in p orbital to get the group to which this chlorine belongs to. Therefore, this is 3s2, then 2, then 3p5 plus 5, and it gives us 7. Therefore, chlorine belongs to group 7, and it belongs to period 3 of the periodic table. And therefore, it is what? A p block element. P block element. I'm sorry, my camera isn't clear for the view, isn't clear. So I hope you can learn it from my voice record. So applicable, let's go to sodium in a sharp manner. This is sodium and it has 11. Therefore 1s2, 2s2, 3s2, sorry, 2p6, 3s2, 3p, this is 10, sorry, this is 10, and now this is 11. So therefore, sodium is in group 1 of the periodic table. Group 1 of the periodic table, period 3 of the periodic table, and is an S block element in the periodic table. S block element. Then potassium of 19, atomic number of 19, 1s2, 2s2, 2p6, 3s2, 3p6, 3 pieces. This is what? 10, 18. Then 4s1, this is another case. Instead of 3d, then we'll put 4s, because 3d has a higher energy level than the 4s. Therefore, potassium is in group 1, block X, and period 4 of the periodic table. Then argon has 18. Yeah, 18. Then 1s2, 2s2, 2p6, 3s2, 3p6. This is 18. Therefore, for locating the group, we will now plus the S block and the P block substituent, which is 2 plus 6, which is equal to 8. It belongs to group 8 of the periodic table, P block element, and period 3 of the periodic table. This is just a simple terms on how to get the periodic table. By so then, how can you note or understand that yes, what we are doing is correct? Then let's draw the periodic table inside hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. 1, 2, 3, 4, 5, 6, 7, 8. Argon is in group 8, as we did here. 2 plus is 8. Chlorine is in group 7 of the periodic table, as we did. 5 plus 2. Sodium is in group 1 from here. Then period, we have 1, 2, 3, 4. If you go through them, you later analyze that yes, what we did here is basically correct. Thank you very much for listening. This is just a preview of the periodic table in simple terms. Thank you very much.